Hi, this is a presentation on the networking OSI model. The Open System Interconnection Network Model is a network model developed by the International Standards Organization. The OSI model consists of 7 layers that describe communication between 2 nodes or computers. The OSI model specifications enable computers across the world to be able to communicate with each other. This was established in the early 1980s by the ISO. Within a single machine, each layer of the OSI calls upon the services of the layer just below it. Layer 3, for example, uses the services provided by Layer 2 and provides services for Layer 4. Networks operate on one basic principle, and that's to pass it on. Each layer takes care of a very specific job and then passes the data on to the next layer. The OSI model is built of 7 ordered layers. Starting from your transmitting computer, the data will travel down through the application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer, where then it will travel across a physical link into the receiving computer, starting at the physical layer, moving up to the application layer, and then into the receiving computer. Layers 1 through 4, physical, data link, network, and transport, are considered the lower layers. They mostly concern themselves with transmitting raw data between 2 computers. Layers 5 through 7, session, presentation, and application, the upper layers, are concerned with communication between application level data. Some acronyms to be able to remember your layers in the order that they belong are: please do not throw salami pizza away, and please do not tell secret passwords anytime. This works from bottom up. Each letter of each word representing the first letter of one of the layers, starting with please, which would be physical, data link, network, transport, session, presentation, and application. Now I will describe the layers and their responsibilities. The physical layer. This layer determines and deals with transmitting and receiving bits across a physical medium. Physical mediums can include copper cable, coaxial or twisted pair, fiber optic cable, or radio channel. Hardware devices can include network interface cards, fiber optic transceivers, radio transceivers, and modems. The only concern of the physical layer is to transmit a signal across a physical medium that represents binary bits, or the zeros and ones. It does not have any knowledge of the meaning or structure of the data itself. It only acts as a conveyor belt that has no understanding of the package it carries. The data link layer is logically subdivided into 2 sublayers, the media access control sublayer and the logical link control sublayer. The LLC layer maintains the link between 2 computers by establishing service access points to specify a destination address for a connection. The MAC layer is used to coordinate the sending of data between 2 computers. This is the physical address of the receiving computer. If you hear someone talking about a MAC address of a network card, they are referring to the hardware address of the card itself, and this can be found by running ipconfig/all. Responsibilities of the data link layer include framing, where the data link layer divides the stream of bits received from the network or physical layer into data link or data units called frames. Physical addressing is also done. If frames are to be distributed to different systems on the network, the data link layer adds a header to the frame that defines the physical address of the sender, source address, and/or receiver, destination address of the frame. If the frame is intended for a system outside the sender's network, the receiver's address is the address of the device that connects one network to the next. Hubs and switches operate at the data link layer. Here is a graphic of a generic data link layer frame. This is a structured package for moving data. It includes the raw data or payload, the zeros and ones, along with the sender and receiver's network addresses and error checking and control information. When we talk about control information, there are 3 types of controls: flow, error, and access. Flow control. If at the rate at which the data is being absorbed by the receiver is less than the rate produced in the sender, the data link layer imposes a flow control mechanism to prevent overwhelming the receiver. Error control deals with adding mechanisms to detect and retransmit damaged or lost frames. And access control provides protocols that are necessary to determine which device has control over a link at any given time. The network layer. This layer just deals with getting the data to its destination using the best route possible. It translates network addresses and decides how to route the data. Routers belong in the network layer. The transport layer. Protocols in the transport layer accept data from the session layer and manage end-to-end delivery. It ensures that data is transferred from point A to point B reliably, in the correct sequence, and without errors. Without transport layer services, data could not be verified or interpreted by its recipient. It breaks information into packets, each packet having a sequence. Another key function of the transport layer is that it provides connection services for the protocols and applications that run at the levels above it. These can be categorized as either connection-oriented services or connectionless services. A connectionless transport layer, UDP, treats each segment as an independent packet and delivers it to the transport layer at the destination machine. A connection-oriented transport layer, TCP, makes a connection with the transport layer at the destination machine first before delivering the packets. After all the data is transferred, the connection is then terminated. Some transport layer protocols take steps to ensure that the data arrives exactly as it was sent. It is involved in sequencing, identifying segments that belong to the same group, and it reassembles longer messages that were divided into smaller messages. And here's a graphic that is a representation of that, where the sending computer has a long message and the transport layer segments that message into a bunch of shorter ones, so it'll travel across the network easier into the receiving computer, where then it's reassembled back into the long message to be handled by the receiving computer. Protocols in the session layer coordinate and maintain communications between two nodes or computers. Session refers to a connection for ongoing data exchange between two parties. Session layer functions are establishing and keeping alive the communication link for the duration of the session. It keeps the communication secure, it synchronizes the dialogue between two nodes, and it determines whether communications have been cut off, and if so, figuring out where to restart transmission and terminating communications. Protocols at the presentation layer accept the data and they format it. They take the zeros and ones and they convert them into a code called ASCII. Presentation layer protocols perform the coding, compression, and also manage data encryption and decryption. The presentation layer serves as a translator. The application layer. This layer provides a means for the user to access information on the network through an application. This layer is the main interface for the user to interact with the application and therefore the network. This layer does not include software applications such as Microsoft Word or Excel. Instead, it serves as a translator and determines what application is going to open the data. It communicates between the software programs and the lower level services. File, print, message, database, and application services work through this. And this is the end of my OSI model presentation. I hope that it could help some of you and clear up exactly what each layer is responsible for. Good luck in your networking studies.